In this video, we're going to be demonstrating just how easy it is to go from a blank slate to a working ECU through the use of Innovo's OpenECU. Now, for the purpose of time, we're going to be performing a pretty simple task of activating a warning lamp when our temperature sensor reaches a defined limit. But by walking through this little project with us, you'll be able to see just how smooth the workflow is and how many of the tedious pieces of the process are handled for you behind the scenes. Finally, we will demonstrate how our build process converts the model into an executable file without any user intervention. Let's get started. We're going to start off by calling OE create model at the MATLAB prompt. This command creates a new OpenECU model and makes sure all the settings are correct. Next, we're going to tell OpenECU to create a model called lamp control and a data dictionary called LMP. It's a pretty small command that does a ton of things in the background. Now, you've probably noticed that there's only one block in the model at this point. For this demo, we're going to use the M461 ECU. Let's configure our model for our hardware. We'll just fill in these boxes here and click OK. We need more Simulink blocks to work with, so let's go to the OpenECU Simulink library. We need to add the input signal for the temperature sensor. This is an analog input, so we'll grab one of those from the library. Let's use pin A16 for this, and we'll sample at 10 milliseconds. We're also going to need an output block to drive our warning lamp. We'll use a digital output on pin A7. Alright, let's go in and add our control logic. What we're trying to do is compare the temperature sensor against a threshold and turn on a lamp when it goes over. We're going to grab a couple more pieces from the library to help us do this. Let's grab a relational comparator block and a constant block. Now we're just going to connect these blocks. Now we want our calibration tool to monitor some of these signals, so let's give them labels. We'll define them in the data dictionary later. Because we're using a calibration tool, we'll need to configure our CAN bus for communications. For that, we're going to grab another block from the library. We'll also make this our CCP communications bus. If you remember in our test model, we created two display signals and a calibration variable. The data dictionary tells OpenECU how to handle them during the build. Let's do this now in the LMP data dictionary we created at the beginning. Here you will see we are creating entries for scaling, range, data type, and calibration value in our data dictionary. All we have left to do is have MATLAB read in the data dictionary we just created. We will use the OE read build list command. Now let's click build and watch the software create a flashable S-record file. This is where OpenECU really shines. You'll notice that we don't have to do anything during the build. The whole process is automatic, and a model this small is finished in just a few seconds. Now let's go to our calibration tool and flash the files onto the ECU. You can use any CCP compliant calibration tool to do this, such as ATI or Vector. But for this project, we will use Innovo's calibration tool called PySnoop. To save time, we have a pre-configured workspace with the CAN communications, files, and a measurement window. Let's go ahead and flash the ECU with our software. Alright, now for the fun part. On the right side of the screen, you can see a watch window with the signals and calibration variables we defined earlier. Now that the flash is complete, we can go online and monitor these signals live. Off-screen, I'm adjusting a potentiometer on my test bench to simulate the temperature sensor input. As the voltage goes over the calibration limit, you can see that the output lamp goes on. There you have it. In just a few minutes, we were able to go from a blank slate to a functioning unit through the use of OpenECU. You probably noticed just how little we had to do to generate the hundreds of lines of code needed to perform this simple task. Now imagine what your next project could look like if you use the OpenECU library to streamline the process and deliver your project in less time and with a lot less headaches. Contact our team for more details today.